about systems of equations and solving them graphically. So the first thing we'll do is we'll practice graphing some different functions, starting with the lines. So whenever we have the linear function in this form, y equals mx plus b. Oh, I need to. So whenever I have a system, a linear function given to me in this form, y equals mx plus b. My m is what? The slope of the line, very good. And b is what? The y-intercept of the line. Okay. So what is the easiest way to graph this line? We'll start with the first example. Y equals negative 1 over 3x plus 4. What is the y-intercept? Yes. 0, 4, right? Each point has x and y coordinates, so 0, 4. 1, 2, 3, 4. Here is my y-intercept. And then what do I do? How do I use slope to get the second point? Yes.
So, since it's negative, you just go down 1 over 3, down 1 over 3, and then you want to space to go 1 over 3.
Very good. So slope, what Isaiah is saying is that slope is basically rise over run. So whenever the slope is positive, you go up for the rise. Whenever the slope is negative, you go down for like negative rise. And the run is always from left to right. So negative 1 over 3 is the slope. Negative slope tells me that I need to go 1 down for every 3 units to the right. If I start this y-intercept, the point that I get is 3, 3. And then I just connect these points to get the line. Any questions about this? Did I do something wrong?
No.
Yes, Hannah. All good? So let's try another one, the second one. What do I need to do here before I can graph? I need to change the formula. I need it in the slope intercept form. So what do I need to do to this equation so that I have the formula that looks like? So I will do minus 4x first, which gives me negative 3y equals
Then you need to divide.
negative 4x plus 6. And then I do it?
Divide by negative 3,
I
and then it
divide.
makes a positive 4 over 3.
Very good. I divide everything by negative 3, which gives me new formula y equals 4 over 3x minus 2. Don't do that.
I don't know what
Can
you're
you
talking
see?
about.
You don't? Sorry.
My apologies.
It's all your fault. I knew it.
Okay, so now I have the function in the slope intercept form. So the first thing I do, I find my y-intercept, which is what you? Negative 2, 0, negative 2. Be precise. 0, negative 2 is my y-intercept, and then my slope is 4 over 3. So what do I do to find the next point?
Go up 4 and then to the left 3.
Up 4, 1, 2, 3, 4, left, right 3, 1, 2, 3. So here is my second point. And then I just connect the points. And this is my line. Any questions about this? Good. So lines are easy. We've done them forever. Parabolas. This should be easy now too, right? We've done these for the last 3 days. 3 classes. Okay, so parabola we can have in standard form or in, what is this form called?
The double form.
How do we call this form? Vertex form, right? Vertex. Okay, so whenever we have the second form for our quadratic function, what is the HK point?
Vertex?
Vertex of the parabola. And we know this, why? Because if we start with the parent function, parent parabola y equals x squared, and apply some kind of transformations to it, we will get this generic parabola. And what kind of transformation happened from the parent to this one? What transformations do you do to the parent function y equals x squared to get the function y equals a x minus h squared plus k? Remember transformations? What does the a tell us? Compress or stretch the parabola, right? What does the h tell us? We move parabola right or left, and what does the k tell us? We move our parabola up or down, right? So if I start with the vertex in mind, stretch does not affect my vertex of the parent parabola, which is 0, 0, right? Stretch doesn't affect that. And then I move my vertex minus h tells me h units to the right, and then k units up, right? So vertex from 0, 0 moves to hk, right? So remember this, correct? Sort of? Okay.
So
Mm-hmm.
so how do you know which one to use? Like if it's just there?
Oh, so, yeah, we just give it to you in whatever form, right? And you know how to work with either form. With the standard form, how would we graph it? What would you do to graph the parabola if you have the function in the standard form? You probably would use calculator, right? Right? You would figure out the vertex, you would find the points on both sides of the vertex, and you would transfer them here. Yes.
So if it was in standard form, you would use the calculator.
Mhm.
If it's in vertex form, you would just use transformation.
It's really your preference. You could always
But you
use
can't
calculator. I do everything manually. Yeah.
Can I go to lunch?
Yes, let's go to lunch and then we'll actually graph. Okay, so now we are going to graph both parabolas, right? The first one I'll just do using calculator. Okay, so what do I do? Let's see. I'll just take my calculator up or out, and I say y equals, clear everything, make sure that everything is clear, and then I enter negative x squared plus 4x minus 3. Enter, and then graph. Okay, so I have my parabola here, right? And for me to transfer the parabola from calculator to the paper, I need some reference points, right? So I'm making a mental note of where my vertex is. It's at x equals 2, right? And I want the points from both sides of the vertex, just to make sure that, you know, the points will be representative of the parabola shape. So I go to my second table to get the points. Let me see. And then I make sure that my vertex is right here. 2, 1 is my vertex right here. And I just take the points right here and plug them. All I need is few points, few reference points. I definitely want my vertex, which is 2, 1.
Wait, what did you press to get that table?
Second table, second graph, second table. Table is right here.
Oh, so you press second.
Table. Mhm.
And it'll give you the table.
Yes, of all the x and y's on the parabola. So I can use them to bring my parabola to my paper to graph. So my vertex is right here, 2, 1, right? So this is the vertex.
Is that the vertex or just repeating like number? No, it's in between two repeating numbers.
Right, so it's in between two repeating numbers. That's where the vertex is about. Okay, okay. Okay, so 2, 1 is my vertex, 2, 1 right here. And then my parabola, if you remember, was downward facing, right? So I'm making a note of that also. The points are...
Sorry.
the points around the vertex. That's what I want to plot. All done? Sorry.
I'm sorry.
I'm good. I now have another blanket.
So I go to the left of the vertex. It gives me points 1, 0, 1, and then 0 minus 3, 0 negative 3, and then parabola is symmetrical, so that's what I'm going to do.
Take your blanket.
And I connect the points. Give me this nice looking parabola.
So when you get when you plug it in and you graph it, then you press the second table graph, and then you get the points and you just plot the points.
Yes. Just make sure to choose correct, good points so that you have points on both sides of the vertex. Otherwise, you'll end up with like half parabola, which is not representative of the shape. Yeah. Okay. So, any questions about this? Should be easy now, right? Example number 4. So here we have the quadratic function in what form?
Vertex.
Vertex form. So one way to graph this one is exactly the same as we just did for the previous example. I could plug this formula into calculator, and I could use that. Or I could do transformation. So for transformations, I would start with the parent function. So my parent function is y equals x squared, right? And I'll just graph it. I know the vertex is 0, 0, and then it goes through 1, 1, and through 2, 4, right? And then it's symmetrical around the vertex. This is my parent function. Of course, yes, it is a parabola. It's quadratic function, it's parabola, always parabola. So this is my parent, and now I make note of my transformations. So what are my transformations here?
So left 2.
Say it again.
Left 2, down 4.
Yes, so the transformations left 2, down 4, and that's it, right? So I take my vertex, I take few points from my parabola, and I just transform them. Left 2, down 4.
Does it have a 1, 1 slope?
That was right.
There is
That
no
was
slope.
right.
That was right.
Oh yes, sorry. Should be left. Okay, so left 2, down 4. This is my new vertex. From 0, 0, I move to negative 2, negative 4. And I can just repeat, I can do this for a couple more points, or a few more points. So for this one, for example, from negative 1, negative 4, negative 1, 1, I go to negative 3, negative 3.
So it's a 1, 1 slope.
There is no slope. Parabola doesn't have a slope.
Okay.
Oh, you mean leading coefficient? Yes, it's 1.
Yeah, but it like increases to 1, 2, 3, and 4.
Say again? What do you mean?
I noticed that like for these parabolas,
Uh-huh.
when there's not like a specific slope that it gives you from here,
Mm-hmm.
it tends to go across 1 block, and then it goes across 2 blocks, and then it goes up 3. It just keeps on adding.
Yes,
and
the
adding.
slope changes. That's exactly
adding
the
from one.
yes. When you get to calculus, or is it calculus? Yeah, I guess it's calculus. When you start talking about derivatives, that's exactly what you will do. You will figure out how the slope of all these different lines change, and that forms your parabola. But that's beyond our class. Okay, so from 4, 4, I go 2, 1, 2, 3, 4. So it goes. So the blue is the parent. You don't have to have it. No, I'm just doing transformation. So I start with the parent, and this is actually my parabola in red. Yes.
So for the actual parabola with red, you only need 3 points, like the vertex, and then 2 other points, and then you can just draw the thing.
Well, you don't want to be too sloppy, right? Because you really, like for this one, I would ideally want you to look at the vertex and then the intercepts, right? so that, I mean, the important points are accurate.
So how would you know where the intercepts are? Because how would you know where the intercepts are after that?
You know, here I just took few important points and transformed them, and they happen to be like these. This one happened to be the intercept, right? Or you could just plug in, like for y-intercept, you could plug in x equals 0. For the x-intercept, you could set this whole thing to 0 and figure out the x's, right? With the square root method. Does that answer your question? If you don't want to use calculator, if you are using calculator, you can find out all the important points, right? With your trace function and the calculator, you can find exactly your intercept, you can find your vertex, right? Just from transformations, you can find the y-intercept by plugging in x equals 0 into the function, right? I know that y-intercept, x equals 0, so I plug in 0, 0 plus 2 is 2, squared 4 minus 4 0, so my y-intercept is 0, 0. To find x-intercept, every x-intercept has y equals 0, right? So I can take this right side of the formula, set it to 0, y equals 0, and then I can solve for x, right? And that will give me two different x's for the y or for the x-intercept. Questions here? Okay. The last shape we will review today is the circle. Let's see. So the formula, I don't know if you've worked with circles before in Algebra 1
Yes.
or anywhere. Yes?
Geometry.
Somewhere, right? Some time ago. Okay, so the generic formula for any circle is x minus h squared plus y minus k squared equals r squared, where your h and k is the center of the circle, and your r is the radius of the circle. So looking at example number 5, x squared plus y squared equals 9. Can we figure out what the center of this circle is? What is the center of the circle? What are my h and k?
0.
0, 0, right? Because I can rewrite this formula as what? As x minus 0 squared plus y minus 0 squared, right? And then instead of 9, I could put what? Square root of 9 squared, correct?
Yes.
So
Does that
it's
mean
basically
3?
3 squared,
Mhm.
correct?
Yeah, I have a question.
Yes.
When we go to graph this, are we going to use 9 or 3?
We are going to use 3, right? Because you see in the formula we have r squared, and your r is the radius. So you need to take the square root of 9 and rewrite it as equals 3 squared to understand what your r is, right? So your center for this parabola is what?
0,
0, 0. Not parabola, circle.
The
And your radius is what?
3.
3. Right? So how do I graph this? I find my center of the circle 0, 0, right here. And then because I know that the radius is 3, I go 3 units to the right, and I go 3 units to the left of my center, 3 units down, and 3 units up. This gives me 4 reference points, and I could kind of connect them to have this circle. It's not going to be perfect, but it's representative of the shape we are going for. Right? So I find my center, and then I find my radius, and then I can draw the circle. Questions? Okay. Let's see the second example, or problem number 6 from the notes. Again, this is the circle. You can see that the formula is very much similar to the circle formula, to the circle function that we have, not function, formula. So can we figure out what is the center?
Is it
Center
Negative
x,
1,
y.
Is it negative 1, 2?
Is it negative 1, 2?
No.
Hannah, is it negative 1, 2? Comparing the formula that we have in our example with the standard formula, right? In the standard formula, the center is hk. C minus h minus k. It's 1, negative 2. Right? You kind of have to take the opposite of these numbers. Right? Because you really need to think about this formula that you have as x minus 1 squared plus y minus negative 2 squared equals 4. And then you have it in the form, in the standard form, x minus something, y minus something. Okay, so the center is 1 minus 2, right here. And then what is the radius? R.
2.
It's 2 because we need to take the square root of 4, which is 2. 4 is 2 squared, so 2 is the radius. Okay, so from my center, I go 2 units to the left, 2 units to the right, 2 units down, 2 units up.
You went
I
3.
didn't, yeah, I went too far. On the left, I went too far. And now I can draw my circle. Questions about the circles? Okay, if do we need to talk about this? This is good. Do we need to talk about how to graph this using calculator? The circles? No. Okay. 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 So as we talked about this, right, in the beginning of the class, to find the solution of the system of equations, I would take each equation, I would graph them, right? I would take each of those formulas, I would graph them, yes.
It skips an entire section and it goes to that.
Usually, there's one more.
What do you mean?
There's a part before.
You're missing part.
I'm missing a part?
Oh,
Oh,
there
here.
you go.
Yes, thank you. I skipped. I was doing this one, right?
Yeah.
Okay. Okay, system. Yeah, I was thinking like in the first period I didn't have to explain anything. Okay, a system of equations is a set of 2 or more equations using the same variables. Kind of covered it. When graphing systems of equations, we are looking for the intersections of the graphs, one graph per equation, that are called solutions. We kind of talked about this at the beginning of the class. So there are 3 options, right? 3 scenarios that you could encounter. Sometimes we will have 2 graphs and they do not intersect at all. So how many solutions will this system of equations have?
2.
Right here, right? I have a parabola right here, something like y equals x squared plus 6. And then I have this circle, which is x squared plus y squared equals, what is it, 525, right? So here is the system of 2 equations. I graphed each of these on the graph, and this is exactly how they look. Do you think how many pairs of x, y will be such that satisfy both of these equations?
None.
None, right? Because the first graph, this first line parabola, represent all the pairs xy that satisfy my parabola equation. This one. And then my circle represents all the xy pairs such that they satisfy the second equation, the circle formula, right? None of the points xy satisfy both. So we have no solutions to this system. No intersections of the graphs mean no solutions to the system. What about the second example?
2 solutions.
Right. So in this example, we have exactly 2 solutions, right? We have a line and the circle, and they intersect in 2 points. So these 2 points will satisfy the equations for both of these graphs. So the second scenario, we can have number of solutions, number solutions.
Oh, it's just not
We-
two?
Sometimes we could have 1, sometimes 2, 3, or many, depending on what graphs we are talking about. For this particular one, we have exactly 2 solutions. Right? But if, for example, I have 2 lines that intersect, there will be just 1 solution, right? And if my graph is some kind of like weird, and I can have many solutions, right? Okay. And then there is third scenario like this one, when we have, well, in this particular case, we have 2 parabolas that overlap. One is on top of another. So 2 equations that are exactly the same. I have system of equations that one says y equals x squared, and another one says 2y equals 2x squared. Right? Different looking equations, but they are essentially the same. If I divide the second one by 2, it will be exactly the same formula. So if I grab the first one or the second one, the graphs will look exactly the same. So how many solutions do I have here for this system?
One?
All real?
Not all real, but infinite number of solutions, right? Any x will, I can plug in any x and get some kind of y. This pair will satisfy both equations, the infinite number of solutions. Infinite number of solutions. When the graphs overlap in at least some kind of section. Questions? Okay. So looking at these examples, how many solutions do the following systems of equation have? This should be systems. Right, so you have this first graph or first picture. It represents system of equations, of 2 equations. The one equation is quadratic. The second one is this, the circle formula. So how many solutions will this system have?
4.
4. Correct. So we have 1, 2, 3, and 4. 4 solutions. Good. What about the second one? Natalie, how many solutions do you think the second system have? Do we see any
0.
intersections or any intercepts between the 2 graphs?
Not that we know.
No, right? So we will assume that they will never cross. So how many solutions will we have?
0.
No solutions.
Hmm.
0 solutions. And finally, the last example, number 3. Leah, how many solutions do you have this system of equations have? 1 solution. You have 2 lines and they cross in exactly 1 point. 1 solution. Questions about this? Okay. So here we'll not only determine how many solutions we have, but also let's try to figure out what are the solutions, just by looking at these graphs. So the first one, what is the solution of the system of equations represented here in this first picture?
None.
Hannah. No solutions. The 2 circles do not cross ever. What about the second one? Can you figure out what are the solutions to the system of equations
-1,
represented
2.
here?
There's
So the first one, negative 2, 5.
Hmm.
Negative 2, 5. Looks like to
1,
me.
2.
Then what about the second one?
1, 2.
1, 2. So when you are asked about the solutions to the system of equations, you just write them as xy pair and then put a comma between. So the first solution xy and the second solution xy. 2 pairs, right?
Mhm.
What about the last example? Grab it.
One.
Yes, they did.
Oh, 0, -4.
0, -4. So one single solution. 0, -4. The graphs kind of just touch at one point. Single solution. Okay. Another type of questions you might encounter somewhere on the test or cell or whatever. Looking at the graph representation of the system of equation, can you determine whether or not a specific point xy pair is the solution of this system of equations? So looking at this first example, is 1, 3 a solution to the system of equations?
Yes, for the first one.
Yes. Jose, do you agree? Yes. Everyone agrees? It is a solution, right?
Mhm.
Because it's right here, the point is right here, and it's exactly the intersection of the two graphs. 1.13, yes, it is a solution. It satisfies both equations. The equation that gives us our parabola and the equation that gives us our line. 1, 3. What about the second example?
None. No. Zip
No,
line,
says Mary. Everyone agrees?
Mhm.
Lily, do we agree? So the answer is no. And why?
Because even though it goes through the point, it's not, the circle and the line are not touching at the same point.
Right. So this point 1, 3 satisfies the equation that gives us our line, right? It's on the line, but it's not on the circle. So it will not satisfy one of the equations, the circle equation. Questions about this? Okay. So now we'll actually get to solve. So we have a system of equations, right? This first example, what kind of functions are these?
Slope intercept.
Yes, so these are both linear functions, right? Both equations, if we graph them, will give us a line. And we need to figure out what the solution is. So where do these lines cross? So before I graph, what do?
So then y equal.
Yes, I want them in the slope intercept form. So I want to take the first one, I'll just do it here. The first one, 3x plus 2y equals 6. I do minus 3x to both sides, which gives me 2y equals negative 3x plus 6. And then I divide by 2 both sides, everything. So I have y equals negative 3 over 2x plus 3. So I can plot the first graph. What is my y-intercept? Dylan, what is my y-intercept for this first line?
3.
3, so 0, 3 is the intercept, y-intercept, and then my slope is negative 3 over 2, so how do I find the second point?
Right 3 down 2.
Is it right 3 down 2?
No,
Down 3, right 2, right?
3.
So it gives me the point 2, 0. And now I can graph. Okay, so that's the first line. Let's do the same for the second one. 2x plus 4y. Let me change. 2x plus 4y equals 8. So I do minus 2x to both sides to have 4y equals minus 2x plus 8. And then I get rid of 4, divide everything by 4. Now I have y equals
Negative 1/2.
negative half x plus
2.
2. Okay, so I find my y-intercept is 0, 2. And then I find my intercept is negative 1 over 2, so down 1, right 2. I connect. As you can see, a few more. So that's exactly a line. Yours is perfect, I'm sure. Okay, so I can, my graph is not perfect, but I can guess what the intersection is. Can somebody help me? What do you think the intersection is? What is the point where two lines cross?
It kind of looks like 1, 2.
Well,
It's 1.2.
it's 1 and 1.5, right? 2, like this. You think so?
Mm-hmm.
No, I think it's 1.5.
Yeah, 1.5.
And you know what? When you're not sure, right? I'm guessing just by looking at this, I think it's 1.5. So what I can do when I guess is I can check my solution, right? And how do I check it? I take my xy point and plug it into the original equations, right? So let me do that. For the first one, x is 1, so 3 times 1 plus 2 times 1.5 equals 3 plus 3, 6. So the first one checks. This point that I found belongs to the first line. Now I'm checking the second one. So 2 times my x is 1 plus 4 times my y is 1.5 equals. So 2 plus 6 is 8. Check. So yes, I guessed correctly. This is what you want to do when it's not like perfectly clear. You want to guess and then check yourself. Are you good?
Yes.
Or if we don't want to play guessing game, you have the calculator. So how do we do this using calculator? Let's just do that. I bring up my calculator and I graph both functions. So I go to y equals, clear everything. The first function is what? The first graph, y equals negative 3 over 2. So right here, y equals negative
3 over 2.
Is it in parentheses?
parentheses, yes, parentheses. Negative 3 divided by 2, x, what was it, plus 3. Plus 3. And then I go to the
There's
second
no plus in
one.
between.
Oh, there's no plus.
Just replace the 3 with the plus sign.
Yeah, I learned that. Plus 3. Okay, good. And then the second one, what was it? Negative 1 over 2, right?
Uh-huh.
Negative 1 divided by 2,
Plus 2.
x plus 2. Okay, so now I enter two functions. I say enter and I graph them. So here are two lines on my graph. And now I will look for the intersection. So I go to the second trace and I look for intersect. So it's 5. And it's asking me on the first curve, where it's asking me to calculate the approximate location of the intersection I'm looking for. Okay, so on the first curve, I come close, very close, bring this blinking thing very close to my intersection and say enter. Now it's asking me for the second curve. And I'm pretty close to the intersection, so I just say enter. And then it's asking guess. Yes, please guess. And the intersection is 1, 1.5. Gives me the coordinates of that intersection. Okay? So we confirmed our guess. 1, 1.5. We were right. Questions? Okay. So let's do the second one together and then you'll try on your own. Okay. Huh? Okay, so what kind of shapes will I expect for these two equations? If I graph these two equations, what shapes will I get? One parabola and another one?
Circle.
Line. You're not even looking maybe. So y equals to x is what? Y equals to x will give me
0.
a line, right? Line. So my for this line, my y-intercept is where? 0, 0. And then the slope is 2. So I have 2 rise over 1 run. So 1, 2, and then I have this and this. So So my line looks something like this. And now I'm graphing the parabola. This one is easy, right? It's parent function, no transformations. So I know my vertex is 0, 0, right? Or I can just plug in 0 and see 0, 0 is my vertex. And then if I plug in 1, I have 1, 1. And then for 2, I have 2, 4. And it's symmetrical, so that's easy. And so I have this nice, simple parabola. How many solutions does this system have? 2 solutions. And what are my solutions?
0,
0, 0 is the first one. This is my first solution. 0, 0. And where is my second solution? Where is it, Jose? What is the point? 2, 4. Right here. Second solution. Again, I can easily check them, right, by plugging them in. So check right here. So for the first one, y equals 0, 2 times x equals 0. So that checks. 0 equals 2 times 0. And for the second one, y 0, and then x is 0. So 0 squared. Checks, right? So we check the first solution. 0, 0 satisfies both equations. All good. And now we need to check the second one. We're gonna check the second one.
Isn't there a third one?
Huh? No, there's no third one.
For
Because parabola will only
Never
go up
mind.
more and more, like the slope will always just increase and increase. Yeah. Okay, so to check the second solution, let me just take this right here. I'll just do it in the same spot. Okay, so checking the second solution, 2, 4. So 4 should equal 2 times 2. Checks, right? 4 is y, 2 times x, which is 2. Check. And then for the second one, 4 should equal 2 to the power of 2. Also check. Right? So the second point that we found also satisfies both equations. So all good. Or you could do this using calculator. No questions?
No
Questions?
No.
Any concerns?
No.
Okay, so we already did this, right? How to do this using calculator. Covered everything. So look over it. And now you can do some practice. Are you ready to practice by yourself?
Yeah.
Yay! Okay, let's do that.
Hey, golly.
She doesn't.
All right, so number 3, circle, parabola. Number 4 is a parabola and a line. Remember, the trick is no exponents, it's a line. 1 exponent is a parabola, 2 is a circle. Okay?
Yeah.
And the exponent is always going to be a 2, right? Because we're talking about parabolas here.
There's always a 2.
All right? Yeah.
There's 2 circles.
All right, so tell me,
No, it doesn't.
number 5, the first one, how many exponents do you have? 1, so what is it? It's a parabola.
It's parabola.
How about the second one? What is it? It's a circle. Good. Oh, you know what? Let me use a different color. All right, so the parabola, guys, if you can use your transformations or use a vertex form, right? Or put it in the calculator. The vertex for your parabola,
I don't know what you're talking about.
Sure.
what is your vertex here, guys? Opposite of this number
1,
is what?
2.
So 1,
1, -2.
2.
Wait, is
No, not opposite the K, just opposite the H.
It's only opposite when there's
Yep.
a K and a number before it.
So 1, 2, and then my parabola.
That's all right, man. I'm done.
Right? Okay, there's my parabola. And now the other one is a circle, yes? Guys, and you know, for circles, you got to find the center and you have to find the radius. What is the center for this circle? What's the opposite of this number that's inside parentheses with the X?
1, 4.
1. And is there a number inside parentheses with the y?
No.
No, so 0. Okay, x and y, that gives you your x, y for the center. What is your radius?
2.
2, because it's the square root of 4, right? So 1, 0, that's my center. Up 2, right 2, down 2, and left 2.
They are touching.
All my circles are not good at drawing
They're
circles.
better than mine.
But
I think that's a perfect circle.
how many solutions do I have here?
1.
1, right? Where do they intersect? Where do they meet? Right there. What point is that?
1, 2.
1, 2. And please make sure that you tell us the point if it says solutions. You can only tell us how many if it says how many solutions. Yeah? If they say what is or are the solutions, you have to give us the point. All right? All right, and the next one, what are those two?
Circles.
Circles!
Circle.
Circle and circle. Oh my gosh, so hold on, before you put all this away, let me just show you.
Touch.
Do they touch though?
Okay, no. 0,
The center for
0.
this is 0, 0, the radius is 5. This one, the center is 0, 0, the radius is what?
2.
3.
3. Never mind.
So they're both at 0, 0. 1, 2, 3, 4, 5. 1, 2, 3.
They don't touch.
They don't. Why?
Because one of them's bigger than the other. James.
Well, if they both share it.
Yeah, look at this. Okay. Okay. And there you go. No solutions for this because you have a circle inside another circle with the same center. They're never going to touch, right?
Magic.
I'm gonna get my jacket back here in a minute.
Guys, make sure that you do your homework, please.